Hi guys, welcome back. Today we will learn about the rate limiter system. How does it actually work? Okay. So how APIs prevent abuse, how the API providers prevent abuse and overloading. Okay. So you guys have mostly seen an errors like 429, too many requests, or rate limit exceeded. Okay. What does that actually mean? How a server knows that you have made too many requests and how does it stop you making more? Okay, that's what we are going to build today. Okay, so let's suppose you have an API. Okay, it can be any open API, Firebase, GitHub, okay, Stripe, or any payment gateway API. Okay, and there is a user who is going to use your APIs. So user make request 1, 2, 3, 4, 5, 6 up to 10, or maybe the user can make a millions of requests to that API. Okay, so if we don't prevent the abuse of our API, our server will be overloaded. Okay, so if we have a limit on the use of our API for our users, okay, so our users will not be able to abuse or overload our servers. Okay, this is what is called rate limit. Okay, and that's what we are going to work on that. Okay, so stay tuned how we are going to build that. Okay, so let's consider a basic rule before that. Okay, a basic rule is like, what we need to do is we need to allow only 3 requests per minute. Okay, that's our API rule. That's the basic rule that we wanted to have in our API. Okay, so what will happen is that a request 1 came, so we allowed. Request 2 allowed. Request 3 allowed. But request 4, it should not be allowed. Okay, that's what we want to build. Okay, so now the question is how we can implement this rule in our APIs, or how we can enforce this rule. Okay, let's think a simple approach. Okay, in simple terms, what we need to do is we need to store the each request in our database. Okay, our users are requesting the hitting the API. So what we need to do is we need to store each request in our database. So we will store the each timestamp 1, 2, 3, 4, and so on. Okay, of course this timestamp will have the information about the user. Okay, but what we need to do is if we need to check should the user be allowed the API or not, so what we need to do is we need to extract the number of the request made in the last minute from the user. Okay, and then we need to count those requests. Okay, so then if the count is above our limit, we should not allow the user to proceed, so we should stop the user. Okay, but if we are going to now think about it, if we are going to store each request, what will happen is that our database will grow gradually. Okay, there will be a lot of timestamp, there will be a lot of information about the request, a lot of data will be there. Okay, and by the day, by the weeks, by the months, after 1 year, after 2 years, your database will be very large. Okay, so at some time, after some time, like this solution won't work properly. Okay, you will see latency. Okay, so can we optimize this approach? Can we have a different solution, optimized solution to implement our rate limiting? So let's think about that. Okay, let's work on it. So what we are going to do is, okay, please pay attention to that. What we are going to do is we are just going to save the state per user, not every request. Okay, so what we will just save is we will just save first the window start when the user started hitting the particular API according to the window. Okay, the start time. Okay, and the number of requests happened starting from this window, and the limit of the window that we have. Okay, So we are just going to save that, and this will be per user. Okay, so user 1 to 3, user 2 3 4, user X, user Y, user Z. So for each user we will have this thing. And if you see, for each user, the data structure will not grow, database will not grow. Okay, for each user the data structure will remain the same. What we need to do is this count will be updated based on the every request. This window will be updated. Okay, but there will be no more data. Okay, so this database for each user, okay, this structure for each user stays the same. Even it's, if you check it after 1 year, if you check it after, few months or few days, it doesn't matter. Okay, so this will remain the same. Okay, so now I hope you understand the difference between storing each timestamp, okay, or storing a particular state per user. Okay, so we are going to use this particular state. So let's work on the implementation. Okay, so I have already created this skeleton. So what we are going to use is we will have a rate limiter class, okay, where we will pass our limit and window. Okay, so and then we will have a helper function to check if the user should be allowed the request or not. Okay, and then to check that I will be passing the user ID. And yeah, so see here, here I'm using the hash map. Okay, for the users. Okay, if you have watched my previous optimization videos, so you will be, you are familiar with this thing. Okay, so if you have not, so don't worry. This is not the point right now. Here we are just discussing the rate limiter, but I will drop a link about my previous video in the comment, so you can check that. Okay, so let's now focus on this allow request. Okay, so what we need to do is, okay, let's work on that. So first, of course, okay, so we are just saving the getting the current time. Okay, now what we need to do is we need to check if the user should be allowed the request or not. So first what we will check is we will check if our user exists in our database for the rate limiting or not. Okay, so we check is this dot users dot get, okay, user ID. So see get function is, it will just return us the element from the map object. Okay, so if the user is not available in our users, okay, so what we need to do is this dot users dot set. So this is a first time user. Okay, so we will be saving the count. So count will be 0 and window start will be now. So timestamp that we recorded above. Okay, and here this user must be allowed the API. Okay, so this is our first case. Second case is now the user already exists. Okay, so if so let's first get the user. Const user is equal to this dot users dot get user ID. Okay, perfect. So now we will check. Okay, so if the user is going to have a fresh window, so we will allow that. Okay, so to compare that, we will check here if now dot minus user dot we have the window start, right? User now minus user dot window start is greater than our window milliseconds. Okay, so basically this is a new window for the user. Okay, so we will allow this user. So we will just user dot reset the count to 1 and user dot window start is equal to now. Okay, and return true. Okay, so now we check. So now we check, okay, if the user is exists in our database for the rate limiting or not. Okay, so what we need to do is we need to check if the user should be allowed the request or not. Okay, so now we check If so, here we already checked the window. So it is this if it is this window is passed. Okay. So because why we are checking this, because we have this three requests per minute. Okay. So this is the window that we have. So here we are checking if the user window is already passed the previous time that the window started using the API, and the difference between the now and the previous time is greater than the window that we have. So user should be allowed, okay, by resetting the data. Okay, but here it means the user is in the same window. So we will check user dot count is greater than equal to, okay, greater than equal to, uh, we have the limit, right? This dot limit. So user limit is already passed. Okay, so we return false here. Okay, so user limit is already passed, so we are not going to. Otherwise, we are going to do user dot count. We increase the count of the user and just return true. Okay, so see, this is the simple logic that we have. If the user does not exist, so we store the user with a fresh data. Sorry, here the count should be one. Sorry, I missed. So because this request we allow, so current count is one. Okay, so if the user is not there, we allow the user. If the user is in the new window, we allow the user by resetting the data. If the user has already reached the limit of count, okay, so then we don't allow. Otherwise, we increment the count and allow the user. Okay, so this is what. So let's just test it. Here we have this demo. So here I am doing this. Let's put three requests per minute. Three requests per minute. Okay, so let's just test it. So, wait. Yeah, see here. The first request is passed, second request is passed, third request is passed, but the fourth request didn't pass. Why? Because we have a limit of three requests per minute. Okay, so let me just try to make a request every second, okay, for 20 times. Okay, so let's just do that. Let's try it. So our type role is a const interval is equal to set interval. So this we have to call after 1 second. Okay, uh, okay, after 1 second this function will be called. So here we will like const allowed. So we will check limiter dot allow request. So we will say use the same user 123. Okay, we will check. So uh, so console dot log allowed request allowed request rejected. Okay, but I want to do it maximum 20 times. Okay, so I will just use let request id is equal to 0. Okay, so we do is request id plus plus, we increment the id request, we will just print the request id and same we will do it here. So if allowed request 123 allowed request rejected. Okay, so and so this will be calling every if we check the definition of this thing, okay, it's not here, it's fine. But we have to allow it. Let's suppose we want to do it for maximum 20 times. Okay, so request ID equals to 20, and I want to stop. And how do we stop the interval? Clear interval, and here we need the ID also, which is the this interval. Okay, yeah, yeah, and we can just console dot log stop. Okay, so let's just test it. Request one allowed. See, okay, because every request will be rejected, but okay, because we have three requests per minute, so first three requests are allowed, but then are after being rejected. Let's change our limit here. So we wanted to have 5 requests uh, for let's suppose 6 requests per 15 seconds. Okay, 6 requests per 15 seconds, just to test our logic. Request one allowed, two allowed, three allowed, four allowed, five allowed, six allowed, seven rejected, eight rejected, nine rejected, 10 rejected, 11 rejected, rejected, 13, 14, 15, and 16 will be allowed because it's 15 seconds window. Okay, so that's the idea. Okay, this is how the rate limit works. Okay, so thank you guys, thank you so much. Okay, so here uh, the main idea is not just to it's not just the rate limiting, it's understanding how engineers protect systems from abuse and overload. Okay, so we started with a simple basic rule, maximum 3 requests per minute. So then we designed a solution and implemented it. Okay, so that's the same process every engineer use every day when building real world systems or applications. Okay, so thank you guys. I hope you like it. So thank you so much.